we have remote sensing systems. We have several available options. Before we go into the options, we have to see how we characterize those options. So when we talk about remote sensing systems, and we're talking about aircrafts, UAVs, traditional satellites, we can talk even field sensors. We can talk about 4 concepts. Spatial resolution, which is the pixel that's going to be measured by the sensor. So anywhere from 20 centimeters to 250 meters, it's the range of sensors that we use in agriculture. A spectral resolution, number of bands. There is a range of bands that we use, and the sensors captures reflectance in different bands. That's what we were referring to when we talk about spectral resolution. What is the number of bands and the wavelength width of each band? So that's important to know where the information is coming from, and that you don't compare apples with oranges when you see 2 different sensors, information coming from different sensors. Radiometric resolution, which is a sensitivity of remote sensing to variations in the reflectance levels, how sensitive your sensor is. And the temporal resolution, how often are you going to revisit the same area? So we're going to see some typical examples. Before we go into that, this is an interesting figure from a very old remote sensing book from the 70s, but the concepts are still the same. You have temporal resolution in years, so you have from an hour resolution, you can revisit the same location every hour, and maybe you are using a field sensor, to 100 years perhaps, and you have a spatial resolution, maybe from 10 centimeters to 100 kilometers. So here you have different applications. It's the same concept. You have global climate models, which will work in the 100 kilometer range. You have topo mapping, which have to be very accurate, but it's enough with a 10-year revisit. We're interested in crops. At that time, they were thinking about crops in terms of a 10-meter resolution and in terms of weekly or bi-weekly revisits. And also at that time, they had created a line of data volume threshold because the computers were not as fast, the storage capacity was not as much. So that has changed over the years. There's practically no data volume threshold. We can capture and store as much data as we want. And the crops applications have moved more. As we'll see, they can be moved towards the daily or every other day revisit time, and maybe around the 1 meter to 10 meter resolution as the most often used applications. These are some of the satellites, because there are several, just to give you an idea. So we see here the one that we use most is Landsat 8, which has 30-meter multispectral. So when we say, you know what we're talking about when we say multispectral now, they are measuring those wavelengths in different bands, and 50-meter panchromatic, which refers to black and white. So that is the spatial resolution, 15 and 30 meters. A number of bands, they're capturing 9 bands with a swath width of 185 kilometers. Very high, mid-low resolution, but very wide capture. And the temporal resolution is every 16 days, it's fixed. Now, this is public domain. You can download this image, you can process it. What GeoAgroAfrica does is just make it automatic and much faster, because otherwise it would be very, very difficult to use, and other service providers, of course. Now, if you're going to use commercial imagery, you're going to get much higher resolution like Iconos, Spot 6.7, Rapid Eye in the 1 meter to 5 meter range, and then you can control more of the satellite. But the issue with this is that it's very expensive for one farmer. In order to use this, we should have, let's say, 10,000 hectares of 500 farmers, or maybe less, or 100 farmers, or 10 farmers, which is a lot of land. But we need to have a large area in order to make this affordable. The two new kids on the block. It's UAVs, which have been around for the last couple of years. It's evolving very quickly. The advantage is very high resolution, and you can use it anytime. The disadvantage, as you can see, is costs and operational logistics. But that's a technology in evolution, and we'll see more and more in the next years. GeoAgro Africa has a drone, by the way, and provides the service. So be happy to send your. I would be happy to answer your questions after if in that area. And something we're very excited about, it's Nano Satellites. We'll see this in more detail. There are a number of companies from the US. There's one in Argentina that we know of that are working with Nano Satellites. One of them, Planet Labs, that GeoAgro Africa is in touch with now because they are releasing this in trial mode during this year and will be releasing this commercially sometime in the near future, in the next month or towards the end of the year. The impressive thing is that they have reduced greatly the size of the satellites they are producing at large scale. They're launching satellites in the tens or hundreds, and this will allow them to cover daily or 2 days revisit with very high resolution for agricultural purpose in the around 3.7 meters. So those we'll have the traditional satellites, the public domain, the commercial, the UAVs, and the nano satellites. Those are the options that we'll have in the near future.